In this video, we are going to work out some practice problems on polyenes and polyines based on what we learned from our previous lecture videos on IUPAC naming. Let's look at example 1. We have an Alkadiene here, therefore that must be part of the parent chain, this unit. If you stop at that stage, then your parent chain will have 5 carbon atoms and 3 substituents, chlorine, isopropyl and ethyl. On the contrary, if you extend the parent chain to 7 carbon atoms, then you are going to have chlorine, ethyl and methyl groups. Choosing 7 carbon atoms as your parent chain is the correct one here, as that would be longer. Now, how to do the numbering? If we start numbering from here, 1, 2, 3, 4, 5, 6, 7. Then our double bonds are coming at 1 and 4 position. But if we do it on the other way around, then the double bonds will be coming at 3 and 6 position, and that we should not choose. Left to right is the correct way of numbering, and the substituents are at 3, 5 and 6 positions. For this double bond, there is no cis trans isomerism is possible, as we have 2 hydrogen atoms on one side. But for the second double bond, cis trans isomerism is possible. For the purpose of naming, we are going to use the EZ convention. As per the Kahn-Ingold-Prelog rules, which we call it as CIP rules in short, chlorine gets the top priority on this side, carbon will get the least priority on that side, the hidden hydrogen will get the least priority, and then the carbon will get the top priority. Your priorities are on the same side, which means this is a Z isomer. Now, let us mention that in parenthesis first. Therefore, the IUPAC name for this molecule is going to be 4Z, then the substituents in alphabetical order, chlorine, ethyl, methyl. Chlorine comes first, then ethyl and methyl. Therefore, this molecule's correct IUPAC name is 4Z, 5 chloro, 3 ethyl, 6 methyl, hepta, because it is an alkadiene, the A we have to mention it, and then hyphen 1, 4 diene. One could also write the 4Z directly here in this way, instead of mentioning that first in the parenthesis, like 4Z diene, the rest of them are same. However, when you have geometrical isomerism at more than one place, then you have to mention the stereochemistry separately in parenthesis in the beginning, and that is why I encourage you to follow this format so that it will be uniform. Okay, let us look at next example. We have an alkyne and we also have an alkene. Let us do the numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. If we do the numbering left to right, the triple bond comes at 1 position, double bond comes at 8 position. Let us do the numbering on the other way around. Now, if we do the numbering right to left, double bond comes at 1 position, triple bond comes at 8 position. In this case, the substituents are at 6, 6, the methyl groups. In the other case, the substituents are at 4, 4. There is a tie here. Whenever you have a tie, preference must be given to the double bond, not to the triple bond. You should not look at the substituents numbers here. Even though the substituents are coming at a higher position here, this is the preferred way of numbering here, because we have a tie, and therefore the correct IUPAC name for this molecule is 6, 6 dimethyl total 9 carbon atoms in the parent chain. So, non 1 ene 8 yne. That is the correct IUPAC name for this molecule. Let us look at example number 3. Here we have an Alkatriene and therefore, this is our parent chain. Let us do the numbering 1, 2, 3, 4, 5, 6, 7, 8. This is the correct way of numbering because that would give the lowest numbers for the double bonds. The double bonds are coming at 1, 4 and 6 positions. And the substituents, there are 2 substituents are there. One is ethyl, another is methyl, both at 3. The substituents are at 3 positions. Now, for the double bond that is at number 1, there is no cis trans isomerism is possible because we have hydrogen atoms both sides and therefore no cis trans here. But at 4 and 6, cis trans isomerism is possible in both the places. That we need to mention it first. So, at 4, the hydrogens are pointing downwards and that means that if we assign the priorities as per the CIP rules, this will be 1, this will be 2, the hidden hydrogen here, this will be 2, this will be 1 and therefore, this is Z. At 6, the hydrogen atoms are on the opposite side, carbon atoms are also on the opposite side. So, that is a trans one. So, if we assign priorities as per CIP here 1, 2, this is 2 and this is 1 now. So, here it is E and that we need to mention it first. So, the IUPAC name for this molecule is going to be 4Z 6E, that in parenthesis, and then 3 ethyl 3 methyl octa, because total we have 8 carbon atoms in the parent chain. So, octa 1, 4, 6 triene. That is the correct IUPAC name for this molecule. Let us look at example number 4. Do we have an Alkadiene here? No, we do not have an Alkadiene here, though we have 2 double bonds. One double bond is inside the cyclic structure and one is outside the cyclic structure. Whenever a double bond is branching off from the longest chain or cyclic structure, the branch stem ends in ylidene. This one we are going to call it as methylidene as it has 1 carbon atom. In earlier literature, we used to call this as methylene, but it is better to use the term methylene when you have carbon-carbon single bonds connected to the functional groups. For example, if you have something like this, then this molecule is called trimethylene diamine. Isn't it? So, it is better to reserve the term methylene when you have carbon-carbon single bonds connected to the functional groups. So, it is better to use the term methylidene when you have a carbon-carbon double bond attached to a parent chain, just to avoid confusion. Our parent chain here is cyclohexene. That is our parent chain. Now, how to do the numbering? If we start numbering from the carbon-carbon double bond that is there in the cyclohexene ring, then 1, 2, 3, 4, 5, 6. Here At 3 you have methylidene and 6 you have methyl. On the contrary, if you do the numbering starting from here 1, 2, 3, 4, 5, 6, in that case at 3 position you will have methyl and then 6 position methylidene. Should we give preference to the double bond in this case? No, we are not going to give preference to the double bond here as it is a substituent. This unit that is right here is a substituent and therefore we have to go for the alphabetical order because both are 3 and 6. The substituents are at 3 and 6 position. So, in terms of alphabetical order, methyl wins because until here everything is same, but after that you have more letters and therefore methyl wins, and therefore the correct IUPAC name for this molecule is 3-methyl (6-methylidene) cyclohex 1-ene. That is the correct IUPAC name for this molecule. Let us look at example number 5. Here both the double bonds are branching off from the cyclic structure. So, our parent chain is obviously the cyclohexane ring, that is our parent chain. And now here on one side we have methylidene, on the other side we have ethylidene because there are 2 carbon atoms are here. So, we have ethylidene on one side, methylidene on the other side. If you start the main chain numbering here 1, 2, 3, 4, 5, 6, then ethylidene comes at 1 position, methylidene comes at 4 position. Even if you start numbering on the other way around, it will still be 1 and 4. We have a tie here, the alphabetical rule breaks the tie and therefore the way we numbered in red is correct, and thus the IUPAC name for this molecule is 1-ethylidene (4-methylidene) cyclohexane. That is the correct IUPAC name for this molecule. Let us look at example number 6. Which one to choose as a parent chain? If we start numbering from here 1, 2, 3, 4, 5, 6, 7. We have 7 carbon atoms. On the cyclic ring we have 6 carbon atoms. We have to choose this one as our parent chain because that has the double bonds inside the cyclic ring, and therefore that is our parent chain, not the heptyl chain. This will be a substituent. The heptyl chain will be a substituent and the ethyl groups on the other side is also a substituent. How to do the numbering here? If we start numbering from here 1, and then 2, and then 3, and then 4. The double bonds are at 1 and 4 position. On the contrary, if we do the numbering in this way, it would look like the double bond is coming at 1 and 3 position, but that we should not choose because once you start the double bond you have to complete it, and therefore the 1, 4, the way we numbered first is correct. This is correct here. Our parent chain here is a cyclohexadiene and we have a heptyl chain as a substituent and also a ethyl group as a substituent. Between ethyl and heptyl, ethyl comes first, and therefore the IUPAC name for this molecule is 1-ethyl At 4 position that heptyl chain is there. So, it is like a complex substituent. So, 4 in bracket hept 1-yl and then cyclohexa 1,4 diene. That is the correct IUPAC name for this molecule. Let us look at next example. If it was a simple cyclohexane ring without the double bond in this way, then we can obviously start numbering this way 1, 2, 3 because this is most substituted, 2 methyl groups are there. But here we cannot do that. Even though 2 methyl groups are there, we must give preference to the double bond and therefore the numbering has to start from here 1, 2, 3, 4, 5, 6. That is the correct way of numbering here. So, 1, 5, 5 trimethyl cyclohex 1-ene. That is the correct IUPAC name for this molecule. For this molecule without the double bond, if it was without the double bond, it will be 1, 1, 3 trimethyl cyclohexane. Let us look at next example. Let us look at example number 8. Here our parent chain is Cycloalkatetraene. That is our parent chain. As substituents, we have an ethynyl, that is here, and we also have an propenyl group, that is here. This propenyl group must be mentioned as a complex substituent because that has a double bond and that double bond does not start at position number 1. So, if we do the numbering here 1, 2, 3, it rather starts at 2, therefore, the position of that double bond needs to be mentioned precisely. Let us do the numbering. If we do the numbering for the main parent chain 1, 2, 3, 4, 5, 6, 7, 8. The double bonds are at 1, 3, 5, 7 position and the substituents are at 1 position and 6 position. On the contrary, if we do the numbering starting from the ethynyl, then 1, 2, 3, 4, 5, 6, 7, 8. Now, the double bonds are still at 1, 3, 5, 7 and the substituents are still at 1, 6. So, we have a tie here. We can use the alphabetical order of the substituents to break the tie in this case. Between ethynyl and propenyl, ethynyl comes first and therefore, the numbering scheme that is shown in green is correct here. Therefore, the correct IUPAC name for this molecule is 1 ethynyl and then 6 at 6 position and then in parenthesis prop, everything is just one word, there is no space is there. So, that is why I am just writing it down prop 2-ene yl because it is a complex substituent, cycloalkata 1, 3, 5, 7 tetraene. That is the correct IUPAC name for this molecule. Let us look at example number 9. Here we have an Alkadiene. Our long continuous carbon chain is this one. If we start numbering from left to right, then 1, 2, 3, 4, 5, 6, 7, 8. The triple bonds are at 3 and 5 positions, and the substituents, 2 methyl substituents are at 7, 7 positions. On the contrary, if we do the numbering from right to left, now the triple bonds are still at 3 and 5 positions, but the substituents are at 2 and 2 positions. Therefore, this numbering scheme is correct, and thus the correct IUPAC name for this molecule is 2, 2 dimethyl octa, because total 8 carbon atoms are there in the parent chain, 3, 5 diene. That is the correct IUPAC name for this molecule. Alright, let us look at example number 10. Do we have an Alkadiene here? No, we can't choose that as our parent chain. If we do that, then we can't give a name. What we have here is, we have a cyclopropane ring, that is our parent chain, and 2 double bonds are branching off from the ring. Remember, whenever you have a CH2 unit attached to with a carbon-carbon double bond attached to the parent chain, then we need to call that as methylidene. This one is a methylidene unit. So, we have 2 methylidene units attached to the cyclopropane ring, and therefore, the correct IUPAC name for this molecule is 1, 2, 1, 2, 3, 1, 2 dimethylidene cyclopropane. That is the correct IUPAC name for this molecule. Let us look at example number 11. Here, if we choose Alkatriene as our parent chain, then you will have one substituent here, that is ethynyl with 7 carbon atoms in the parent chain. But if you choose this as your parent chain, then you have 2 double bonds and 1 triple bonds with 8 carbon atoms in the parent chain. Now 1, 2, 3, 4, 5, 6, 7, 8. At position 3, we need to mention the stereochemistry, whereas at position 1, we do not have to, because there is no cis trans isomerism is possible at position 1. Also, we have a substituent at 5 position, ethynyl. This is an ethynyl substituent. At position 3, the hydrogen atom gets the least priority, and therefore, as per the CIP rules, this is a Z isomer, because higher priorities are on the same side. So, at position 3, it is Z, that we need to mention it first in parenthesis, and therefore, the correct IUPAC name for this molecule is 3Z and then 5 ethynyl and then 1, 3 diene, drop the additional E, because what comes next is ine, and then 6 ine. That is the correct IUPAC name for this molecule. Let's look at example number 12. If you do the numbering left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9. The triple bonds are at 1, 5 position and the double bonds are coming at 3 and 7 positions. On the contrary, if we do the numbering right to left, now the triple bonds are at 4 and 8 positions and the double bonds are at 2 and 6 positions. So, which numbering scheme to choose? Remember, multiple bonds should be treated as a set. So, in this case, this 1, 3, 5, 7 wins over 2, 4, 6, 8 and therefore, the left to right numbering is correct. This is a correct way of numbering. But we need to mention the stereochemistry at 3 and 7 positions. As per CIP rules, this carbon gets the higher priority here, the hidden hydrogen here gets the least priority, here also hidden hydrogen, that is 2, and then the carbon gets the top priority. Priorities are on the opposite side and therefore, at position 3 it is E. How about at position 7? Once again assign the priorities. Here this is 1 carbon and the hydrogen gets 2, the hydrogen here gets 2 and the carbon here gets 1. Once again the priorities are on the opposite side and therefore, at 7 also it is E. That we need to mention it first. So, mention these two stereochemistry at first in parenthesis 3E, 7E. Total 9 carbon atoms are there in the parent chain. So, Nana and then 3, 7 diene and then 1, 5 diene. That is the correct IUPAC name for this molecule. Alright, let us look at example number 13. Here we need to choose this as our parent chain. We have a complex substituent at position 2. This is a secondary butyl group. Numbering from left to right will be correct in this case 1, 2, 3, 4, 5. Double bond is at 1 position, triple bond is at 3 position and the substituent is at 2 position. If we do the numbering on the other way around, then double bond will be at position 4, triple bond will be at position 2 and the substituent will come at position 4. And therefore, this is numbering from left to right is this is much more preferred because we need to treat multiple bonds as a set. So, here what we have is 1, 3 whereas there what you have is 2, 4. So, let us use the systematic IUPAC name for the secondary butyl group. So, if we number that, then that will be 1, 2, 3. So, 1 methyl propyl. That is the systematic IUPAC name for the secondary butyl group, which is at 2 position, and therefore, the correct IUPAC name for this molecule is 2 because this is attached at 2, that the entire 1 methyl propyl and then 1 methyl propyl then pent because total 5 carbon atoms are there in the parent chain. 1 ene. We don't have to worry about the stereochemistry because no cis trans isomerism is possible at position 1. And then 3 yne. That's the correct systematic IUPAC name for this molecule. If you'd like to use the common name secondary butyl for the complex substituent, in that case the IUPAC name will be 2-sec-butyl and then the rest whatever is there that you just need to mention. That would be the correct IUPAC name if you just mention the common name for the complex substituent. Let's look at example number 14. Here the acyclic system is our parent chain because it has 5 carbon atoms with an alkene unit as well as an alkyne unit. We can't choose the cyclobutene ring as our parent chain because it has only 4 carbon atoms. This entire cyclobutene ring, however, we need to treat it as a complex substituent. So let's do the numbering for the main chain first. So if we do it this way, 1 right to left, 1, 2, 3, 4, 5. In that case, double bond comes at 1 position and triple bond is at 4 position. If we do the numbering on the other way around, then triple bond comes at 1 position, double bond comes at 4 position. We have a tie. Whenever we have a tie, preference must be given to the double bond and therefore this we need to choose. In both the cases, substituent is coming at, the complex substituent is coming at position 3. So let's do the numbering for that one too. So if we do the numbering for the complex substituent, 1, 2, 3, 4. Here we need to give preference to the double bond once again. We cannot do it on the other way around, like giving bromine where the 2 bromine atoms are there, we cannot put 2 there and give 3 position for the double bond. That we are not going to do that. What I mean is 1, 2, 3, 4. That is wrong because we need to give preference to the double bond for the complex substituent too, and therefore this numbering is correct. So the correct IUPAC name for this molecule is, at 3 position you have a complex substituent. So 4, 4 dibromo cyclobute 2-enyl, that's the complex substituent which is sitting at position 3. This 3 refers to this 3. And then pent, because in the parent chain we have 5 carbon atoms, 1 ene, 4 yne. That's the correct IUPAC name for this molecule. Thank you for watching this video, and if you do like this video, consider subscribing it to Chem Media for more useful contents. Thank you.